Hi, this is another episode of Chem Course with Vishwa and Akash. On this show, we cover topics ranging from intermolecular forces to oxidation states. Today's topic is about the differences between covalent and ionic bonds and about the myths and misconceptions associated with them. Now, on with the show.
What is a chemical bond? A chemical bond is a lasting attraction between atoms, molecules, or ions, which allow the formation of chemical compounds. Chemical bonds include covalent bonds and ionic bonds. Atoms form chemical bonds to make their outer electron shells more stable.
What are covalent bonds? A covalent bond is a chemical bond that involves a sharing of electron pairs between atoms. These shared electron pairs are known as shared pairs or bonding pairs. Due to the sharing of electrons, covalent bonds do not have full charges. The two major types of covalent bonds are polar covalent bonds and nonpolar covalent bonds. Since only identical atoms have the same electronegativity value, nonpolar covalent bonding has had its definition expanded to include covalent bonding between any atoms with an electronegativity difference of less than 0.4. Some examples of molecules with nonpolar bonds are O2, H2, and CH4, also known as oxide, hydride, and methane.
As the differences in electronegativity increases, the electron pair in a bond grows closer to one nucleus than the other. If the electronegativity difference is between 0.4 and 1.7, the bond is polar. If the electronegativity difference is more than 1.7, the bond is ionic. Some examples of molecules with polar covalent bonds are H2O or water, and HF and HCl.
What are ionic bonds? An ionic bond is a chemical bond that involves the transfer of valence electrons between atoms. In ionic bonds, two oppositely charged ions are formed. Ionic bonds usually involve a metal, as they have a low electronegativity value and a low number of valence electrons. In ionic bond, the metal loses its electrons to become a cation, which is a positively charged atom, and a nonmetal, which accepts the electrons from the metal, becomes a negatively charged anion. Ionic bonds require an electron donor, often a metal, and an electron acceptor, usually a nonmetal.
Why do ionic bonds happen? Ionic bonds occur due to elements wanting their outer or valence shell to be full. By losing electrons, metals can achieve noble gas configuration. In addition, nonmetals, which usually have close to 8 valence electrons, receive and use the electrons to fill the remaining parts of their valence shells. In ionic bonds, more than one electron can be donated or received to complete the octet rule. Check out our previous episode about the octet rule to learn more about it. The charges of the cation and anion corresponds to the amount of electrons donated or received. The charges of the cation and anion must cancel out to zero. Examples of ionic bonds include NaCl, MgCl2, and Ki.
So now we have a quick quiz for you. Is Fe2O3 or iron oxide ionic or covalent? If you need more time, pause this video. So this is an example of an ionic bond. It is an ionic bond because iron is a metal. In addition, it is an ionic as it is a transfer of electrons. Iron in this form has 3 valence electrons. So 2 iron atoms together contain 6 valence electrons that are given away. Also, oxygen needs 2 more electrons to fill its outer shell with 8 valence electrons. There are 3 oxygen atoms, so in total 6 valence electrons are needed to fill the oxygen atoms' valence shells. They receive these 6 valence electrons from the iron, and thus making it a transfer of electrons, and therefore it becoming an ionic bond. Eventually, due to the reaction, both the oxygen and iron become stable and unreactive with each other.
Another question. What type of bond is phosphorus trichloride? Covalent nonpolar, covalent polar, or ionic? If you need more time, pause this video. This is an example of a nonpolar covalent bond. There is no metal in this bond, suggesting that this is not an ionic bond. In addition, this is a covalent bond as phosphorus needs 3 more valence electrons for stability and as chlorine needs 1 more valence electron. The phosphorus shares one bonding pair with each of the 3 chlorine atoms, giving each chlorine atom and the phosphorus atom 8 valence electrons. Finally, to determine whether it's a polar or non-polar covalent bond, the electronegativity difference must be looked at. Phosphorus has an electronegativity value of 2.2, while chlorine has an electronegativity value of 3.2. The difference between the two values is 1, and this, along with the shape of the structure, makes the compound polar. To learn more about electron configuration and shapes, check out our previous video on that.
Now on to the fun facts and misconceptions. One common misconception related to covalent bonding is that metals cannot be in a covalent bond. This is not true. This is because there is no sharp border between ionic and covalent bonds. Typically, these covalent bonds with metals only use transition metals, but can include other metals too. The transition metal will be paired with another element to create an ionic bond. Some examples of covalent bonds with metals are AlCl3 or aluminum chloride, CuS or copper monosulfide, mercury 1 or He2, and lithium or lithiide.
Another common misconception about the ionic bonds is that ionic bonds must contain metals. This is not true, as there are many ionic bonds that use ammonium instead of a metal. The reason ammonium works as a metal in an ionic bond is because it has a low charge of +1. Therefore, it needs only to get rid of one electron to be stable. Examples of ionic bonds with ammonium instead of a metal are ammonium nitrate and ammonium sulfate.
Whether we know it or not, ionic and covalent bonds are prevalent in our daily life. For example, when we're sitting on the table and feel that our food is bland, what do you reach for? You usually reach for salt or pepper. Salt, or NaCl, is an ionic bond formed with sodium and chloride. Sodium has a charge of +1 and is a metal. And chlorine has a charge of -1 and is a nonmetal. These two combine to form table salt. Another example of a covalent bond that is very important in our life and is present when we breathe is carbon dioxide. Carbon, a nonmetal, has a charge of -4 or +4, they're interchangeable. And oxygen, a nonmetal, has a charge of -2. The carbon atom shares 2 bonding pairs with each of the 2 oxygens, giving it 4 extra valence electrons, which is what it needs. In addition, the oxygens each receive 2 extra valence electrons from the carbon, also giving them 8 valence electrons. Thus, both the carbon and the oxygen are stable.
Thank you for watching this episode, and be sure to stay tuned for more.